Managing all of your own infrastructure can be complex, time-consuming, and possibly expensive, so it's always a good idea to take a look at the managed service offerings from AWS before you go out and architect an application that's built completely on Amazon EC2. It might not always be feasible to use a managed service over building your own servers, but if you find that it will work, you may be able to increase the productivity of your DevOps team and lower your overall costs. Let's take a look at some of the things that you should consider when architecting applications with services rather than servers. So far in this series, we've looked at several of the managed service offerings from AWS. Remember that there's a ton of building block services that you can use to make life easier. For example, you could spin up a multi-AZ RDS database instance that's completely managed, so you don't have to worry about backing anything up or patching anything, and making the database tier in your application highly available is something that this already does for you. But on top of that, there are plenty other managed services that you can use like machine learning, analytics, queuing, notifications, and even email services. All these services are highly scalable, and they can generally help you save costs versus trying to build your own server infrastructure. So just remember, it's a good rule of thumb to try and lead with these managed services when you're designing an architecture for an application, but if there's a limitation and you can't use them, that's fine. Otherwise, you can probably save yourself a lot of work by using some of these managed services. Another common approach for simple websites or basic web applications is to serve static websites out of Amazon S3. In this model, developers can use static content to develop a web application based on HTML, JavaScript, and CSS. And the developers can use JavaScript frameworks like AngularJS that can be used to build really stunning and amazing single-page applications. You can even tie in the JavaScript SDK for AWS so those applications can work with the AWS platform and store data in managed databases like DynamoDB or Amazon RDS. It's also nice to couple a solution like this with Amazon CloudFront, which is the AWS content delivery service. So when your entire website is built using static assets like HTML, JavaScript, and CSS files, all of your content can be delivered from edge locations around the world to users that are closest to those locations. And finally, the concept of serverless is gaining in popularity. You can build an event-driven application for mobile backends, for public-facing websites, or even Internet of Things or IoT solutions. You don't have to manage any server infrastructure in these scenarios. Serverless architectures are a pretty hot topic right now because you don't have to provision any of your own servers, you don't have to make them highly available or back them up. But the way that this works is that you would create Lambda functions that handle all of the operations that you may need to support for a web API. So for example, you might have an individual action to create resources, read them, update them, and delete them. So you'd write a Lambda function for each of those actions using one of the supported languages in AWS Lambda. So you'd use something like Node.js, Python, or Java, and then you would provision an API gateway to act as an entry point for your API. So all of your Lambda functions can be invoked over HTTP using the API gateway. And when you combine this with the static website approach that we looked at earlier, you can build a fully functional web application created with nothing but managed services from AWS. So let's take a look at one example of how you might implement a serverless architecture. So here's an environment using a number of managed AWS services to power a fully functional, public-facing web application. The presentation tier of the application is made up of static content hosted in Amazon S3 and is distributed globally using Amazon CloudFront. So a user on the internet could go to something like www.globalmanix.com to reach the front end of the website. And again, the application front end could be powered by a JavaScript framework like AngularJS and the AWS JavaScript SDK. When the presentation tier needs to do some heavy lifting, it can use a logic tier built with the Amazon API Gateway and AWS Lambda. And this is really powerful because you have access to a variety of programming languages in these Lambda functions, and being able to replace your own servers in this model is something that organizations are already doing with production applications. And finally, your logic tier or your API built using these Lambda functions can access and persist data to database services running on AWS, so you could do something like Amazon RDS, DynamoDB, or others. But this is a pretty good example of an architecture built for a public-facing web application. But keep in mind that you can use the API Gateway and Lambda functions to build your own microservices. Like we discussed earlier, you may have separate components within one large application, and it's not uncommon to see loosely coupled microservice-based architectures use this model. So each component in the stack can be made up of its own API Gateway and Lambda functions, and the components can communicate with each other using standard API calls made over HTTP. Next up, let's take a look at some high availability options and the concept of eliminating single points of failure.